Hello everyone, today in this video we will be discussing the first module of microcontrollers and embedded system. So before moving on, make sure you watch the whole part till the end, and if you like this video, make sure you subscribe to my channel and hit the like button. Okay, so without wasting any more time, let's begin. The first thing you need to know about microprocessor is the difference between microprocessor and microcontroller. So what's the main difference? Both of them have the same components overall, okay, like serial interfaces in both of these, and all the other external components are present here also. But the main difference comes where is all the other devices are connected externally here, but here it's connected internally. Means the smaller versions of each of these device are made and they are embedded in the single board, okay. And one more difference is that the buses are used for the interconnections, whereas in this it's just internally connected, okay. So no buses are used in this case, and the size of the circuit is very much smaller in this and it's larger here. And as you might know that microprocessor came bit before microcontrollers, so this is an older version and this is the new version, okay. So you know the main differences between an older version of something and newer version of something, like the older versions will be much more costlier and they will be larger and it will consume more energy and power consumption will be high, and the opposite will be present in the newer versions, okay. So that's the same thing here also. Those differences are mentioned here, okay. After knowing the difference, the next thing you need to know is what is ARM embedded system. ARM is nothing but the processor, okay. It can be used to make microcontroller or microprocessor. See here, in both of these, microprocessor and microcontroller, the main part is processor here, okay. That is present in both of these, and company has manufactured the processor which is known as ARM, okay. So this processor has some special features which we will be looking in the upcoming topics. So first thing you need to know is what is RISC design philosophy. Means what are the features of RISC design. RISC means the reduced instruction set computing, means it's faster and it has simpler instructions and less instructions. CISC is the older version, so it has complex set instruction computing, so it has more number of instructions and it's hard to execute each of these, okay. So it's a upgraded version of CISC, okay. And as you know that we are moving towards a digital era, so everything is becoming more and more digital, so emphasis is on the software, okay. RISC is designed mainly for the software purpose, and CISC was designed for the hardware purpose, okay. So nowadays more the programs and the devices are using RISC instruction set computing. It's nothing but the rules of writing the instructions for executing any particular program, okay. That's RISC design philosophy. And there are four major design rules in RISC philosophy, which is first is instructions. That means in CISC the instructions were very complicated and more number of instructions, but in RISC the instructions are reduced and are simple, okay. That's the first thing. Second thing is pipelining. Pipelining means if you have to carry out two tasks, first you will not wait till this task gets over. What you can do is before this task gets over, you can start another task here parallelly, so this time will be saved here. That's nothing but the pipelining. And the third one is registers, which means if you have to store any data value, we will use registers, right. So RISC has a large general purpose registers to store more number of data, okay. That's the another feature of RISC. The fourth one is load store architecture, which means the data and the memory is more organized, means load and store are present in different memory locations. I will be looking in more detail in the upcoming topics. Similarly, we have ARM design philosophy. ARM design philosophy has to do with the processor which is manufactured by the company, okay. So this processor is very much efficient because it has been specially designed to have lowest power consumption and extend the battery operation. The second one is high code density, means it's a very small chip and it has a large number of code in it, okay. So it can be used on the devices which are small like mobile phones. And the third one is embedded system. Embedded system is price sensitive. ARM design philosophy, it's smaller in area, but the speed is not reduced and it's very cheap also, okay. And a very great feature which is included in ARM processor is that whatever is happening inside the processor can be viewed on a computer screen, okay. That's connected to computer screen, and the computer engineers can view what's happening inside the processor, so that if any bug is there, that bug will be shown inside the computer and it will be very much easier to rectify it, okay. It's very much similar to the RISC design philosophy, but it's not actually pure RISC design architecture. It has some differences. So let's see what are the differences. see it in the RISC philosophy only in single cycle the instructions are executed, okay, but in ARM design philosophy variable cycle execution is there, means it's not that all the instructions will be executed in a single cycle, some instructions will take multiple cycles also, okay. So that's the first difference. Second is inline barrier shifter, okay, that means before instruction is getting executed the register is being read by the processor, okay, so that will help in much more faster execution, okay. It's like the processor is getting ready for the execution of an instruction before the actual time when it is to be executed, okay, so that will increase the speed. After that we have thumb instructions, thumb 16-bit instruction set, which is another bit instruction set that will add more to the previous 16 one. So total we have 32-bit instruction set now, which can increase the scope of total number of instructions per unit time, okay. And fourth one is the conditional execution. So see, all the instructions will not be executed in the ARM philosophy, only those instructions which are truly necessary that will be executed. How will the processor know if it's necessary or not? It will be specified by a condition, like suppose if n is greater than 0, that time only it should be executed, okay, that instruction. And in ARM design philosophy, enhanced instructions were added to make the instructions much more faster, which is digital signal process, DSP, okay. This will make much more faster instruction set computing, okay. After getting to know about the ARM design, we are going to see about the system hardware and the software. This one is ARM processor, which is the main device in the processor, okay. So this will carry out all the instructions. And second one is controllers. What does a controller do? It will coordinate the important functional blocks of the system, means it will dictate what all the instructions are to be executed. Third one is peripherals, means it will provide the see, this is the input and this is the output, so the connection between the input and the output will be done by the peripherals, okay. And the fourth one is bus. Bus is used for transferring the data. Inside this the internal buses will be connected, so that will help in transferring the data between the input and the output, okay. Let's see about ARM bus technology, which has some theoretical concepts which we'll be going through very quickly. First one is ARM processor. ARM processor is the bus master, which means it initiates the what are the instructions to be executed, okay. So this is the ARM processor, this is the bus master, and the bus slaves are peripherals, okay. So these are the peripherals which will carry out the instructions. Next one is memory, which means the space where you store data, right? That's known as memory. It has the data and the control instructions and the address also. And hierarchy means see, cache is on orders of memory, which is megabytes, okay, and the secondary storage is in the orders of gigabytes, and the cache price will also be very high because it's faster and it's much more costlier, but the secondary storage is relatively cheaper and it's slower also, okay. So this is the hierarchy which you need to know about the memory design. Then we have bit, which means at each cycle how much data is to be transferred, like it's 8-bit transferring or 16 bits is getting transferred at each cycle, or 32 or 64, okay. That's known as width of the memory. Now after that we have some types of memory. First one is read-only memory. It's a fixed memory which is having the data stored permanently, okay. It can't be erased or rewritten. For once the data is stored, it will be stored permanently. Then we have flash ROM. It can be rewritten also, but it's a bit slower than read-only memory, so it can't be used for dynamic memory. Then we have the dynamic memory access. It's DRAM. DRAM is to be refreshed periodically because charges from the capacitor, okay. So since you know that capacitor charges and discharges continuously, so it needs to be refreshed. Then we have static random access memory. This type of memory need not be refreshed, but it is costlier than DRAM because it uses transistors, okay, and it's faster also. So it will be just used in larger databases which requires much more important memory. Next one we have synchronous dynamic access memory, which is used in large databases and it's better than SRAM and DRAM, okay, but it's very much rare, like it will be used in research fields like NASA and all, okay. So it will be very much rarely used. Next we have peripherals, which means the devices which connect the internal and external device, okay. This we had discussed earlier. Then memory controllers are those devices which connect different types of memory to the processor bus, okay. So different types of memory to store different data are present, and the memory controllers are those devices which connect the different devices to the bus, okay. Last topic in embedded system hardware is the interrupt controller. What's an interrupt controller? Interrupt controller is the device which controls the interrupts to be serviced. So what's an interrupt? Interrupt means during the normal execution of a computer program, at that time if any input comes or the error happens, at that time the execution stops and the interrupt is serviced. Okay, so interrupt controller controls those which service is to be done. Okay, so there are two types. First one is standard interrupt controller. What it will do, it will send the processor the signal that interrupt is to be serviced. Second one is vector interrupt controller. What it will do, it is more powerful than the previous one because it prioritizes the interrupts. Okay, after knowing about the embedded system hardware, let's see what embedded system software has. It has four things. First one is initialization of the code, which means I can give you the example of whenever you on your computer system, at that time you can see the black screen, right? And after that some code will be written there, and after few minutes you can see the main screen. After that, which you can use the computer system. Okay, that code which is written there is nothing but the initialization code. Okay, and the second one is operating system. It's the system which has the data and the applications in it, and that can be used as an interface for accessing the applications. And device drivers are nothing but the internal connections between the hardware part and the software parts. Okay, that internal connection is nothing but the device drivers. The fourth one is applications. These are all the applications which you have installed in your system and which you use. Okay, those are known as applications. Then coming to some more details about the first one, which is initialization. It has three steps. First one is initial hardware configuration. Before using the software, it makes sure that the hardware is properly connected, and it can be used with the software. Okay, that configuration is known as initial hardware configuration. Okay, that's the first stage. Second is diagnostics. It's a small test which is carried out to make sure that the hardware is in proper connection with the software. Okay, and the third one is booting. That means it's the last stage before you can use the computer system. In that stage you can see the image which is getting loaded in the computer system, and what happens is the control of the system gets transferred from the memory to the software. Okay, next one is the operating system. That means the main interface by which you can access the application. That's known as operating system. So there are two types. First one is real-time operating system. These are used for the live telecasts, and at that time the changes happen according to the real-time events. Okay, so that's known as real-time operating system. Second one is platform specific operating system. In this the data is stored, like the applications are stored, like in Linux operating system and Windows operating system, the applications will be used, and it's not based on real-time environment. Okay, so it has inbuilt applications. Okay, it's non-real time applications. Then the third one is applications. It means the codes which are written for carrying out the specific tasks inside the computer. That's known as applications, and the processor can handle one or more applications simultaneously. Okay, and these are the applications of the ARM processor in various fields like networking and inject printers and imaging and all. Okay, moving on to the second half of the module, the first topic is ARM processor fundamentals. So in this topic you will be learning what are the fundamental activities happening inside the processor. Okay, so these are the devices which are connected through buses, and each of the device has a particular specific activity. Okay, so let's see the flow of execution. Firstly, the data will be coming from here, and it will be going to the instruction register. Okay, what does instruction register do? It will decode what instruction it is, and it will store the instruction in the load memory. Okay, so see here it's divided into two parts. The register has a first part for loading the memory, and second is for storing the result. Okay, so in load memory, if it's for adding two operands, the operands will be stored here in the load memory, and this is the general purpose register. All the registers will be empty first, and the operands which we got from the instruction will be stored in R1 and R2, and whatever the operation is to be carried out, it will be passed to the buses A and B to the ALU. Okay, ALU will compute the result, and it will be stored in R3 register. Then R3 register will store the result in this part. Okay, in the RISC processor, and finally the result will be transferred to the result bus. Okay, it will be output in the main screen. Okay, that's the working procedure of ARM processor. Every execution of a program, there are two main things. First one is the instruction, and second one is the data. So both of these need to be stored somewhere, right? So this will be stored in registers. In registers we have general purpose and the specific purpose registers. Okay, so the general purpose registers are these, and these will be used specifically when the processor will be assigned some value. Okay, so generally there are three registers, which is R13, R14 and R15, used for specific purposes. Okay, and the processor can be operated in 7 different modes. So let's see what are those different modes. See here, before that you need to know about current program status register. This is the register which is divided into 4 parts. It's of 32 bits, so it will be divided into 4 parts, means 8 bits for each of these, okay. And these 2 bits will not be used, status and extension. It will be kept blank for the future use. And the only bits which we need to focus upon is flags and control. This will have all the control codes in it, and the flags will have the condition codes. The conditional flags will be specifying if the result is a particular result is true or false, okay. So there are many types, like first one is saturation flag. If the result causes an overflow, which means the carry bit is becoming more than what is the space of the memory, that causes an overflow. So at that time q bit will become 1, okay, it will set as 1. Similarly we have v, which is overflow in the signed numbers. And the third one is 0 flag. Like that many flags are there. Like for 0 flag, it is when the result is 0, at that time 0 flag will be 1, okay. And negative flag, when negative result will be getting, that time the negative flag will become 1, okay. And as I told you earlier that processor can be operated in 7 modes. So let's see what are those modes, okay. So there are 2 types. Firstly, first one is privileged mode. In that you can read and write, both operations are possible. In non-privileged mode you can just read the files, okay. So out of the 7 modes, the first 6 are privileged modes, and the last one is non-privileged mode. So in privileged mode, the first one which you have is abort mode. Abort mode means when the process is trying to access a memory, but it has failed to access the memory, it enters a abort mode. The second one is fast interrupt request and interrupt request modes, okay. In that case, if an interrupt is made by any device, or the interrupt is to be executed very fastly, at that time these 2 modes will be used, okay. At that time processor will be in these modes and the interrupt service will be carried out. The third one is supervisor mode. It's the most basic mode which is activated just after the reset, and it's generally used in the basic operation mode, which is in kernel mode, okay, which means it's very much close to the core of the system, okay. The fourth one is system mode. In this it's a special type of user mode in which the full read and write access is given to the CPSR, okay. CPSR means current process status register, okay. Moving on, we have the fifth one, which is undefined mode. In undefined mode, the processor encounters an instruction that is undefined, okay. So the instructions, what is to be done with the instruction is not specified in the memory, so that time the processor enters the undefined mode, okay. And the last one is non-privileged mode, which is the user mode. In user mode, it is used for the programs and applications. We all use the computer system in user mode, okay. So there is some numbering difference in it because I had told you that 6 are in privileged mode and the 7th one is non-privileged mode. Actually these 2 are included in the privileged mode, okay. So in that case, this is first one, second and third, fourth, fifth, then this is the 6th one, okay. These are all in privileged mode. The last one is user mode, which is in non-privileged mode, okay. So total 7 modes are there. Next we have banked registers. Banked registers is the register which is not used by the memory. See here, this is nothing but the banked register. This is used for the future purpose, okay, and it's hidden from the user. You can't see which registers are present inside that mode, okay. So what happens is, whenever processor changes its mode, suppose from the interrupt request mode to the user mode, if the interrupt changes, at that time the registers number will be same, R13 will be same, R14 will be same, just the mode will be changed. So it will be IRQ initially interrupt request mode. If it's changed to user mode, it will become USR, okay. And these two will have separate memory spaces, and just the number will be same, okay. So in abort mode it will be underscore ABT, okay. In like that for all the modes it has some names, okay. The instructions which are written in the computer program are divided into 3 parts. First one is ARM, then thumb and Jazelle, okay. So the differences are very simple in each of these, okay. The ARM is the best, which is 32-bit, then then comes 16-bit, and then the last one, which is 8-bit, okay. And these are some of the features of it. And the Jazelle, it is the mixed instruction of both of these, okay. It's the hybrid of ARM instruction set and thumb instruction set. It's nothing but the instructions which are written in the program, which of the ways it is to be executed, that will be determined by the different types of instruction sets, okay. So the Jazelle, in Jazelle you have 60% of the codes of the Java byte implemented in the hardware, okay. So most of the modern codes are implemented by using the Jazelle code, okay. So this is all about the instruction set. And coming to interrupt masks, it's used to stop a stop a specific interrupt request from interrupting the processor. Okay, whenever processor is busy with some other task, at that time interrupt mask is used to stop any interrupts coming to the processor. Okay, that's known as interrupt mask. Then we have conditional flags, which we discussed earlier also. So it will specify the result if it's true or false. By using conditional flags, we can carry out conditional execution. That means a particular instruction is to be executed or not, that will be determined if the conditional flag is 1 or 0. Okay, at that time the execution will happen when the condition is 1, or else the execution will not happen. The next one is pipelining. Pipelining is nothing but it's parallel execution of the instructions. It means that when the first instruction is getting executed, before it finishes, the second instruction starts and gets executed simultaneously. Okay, so that will save a lot of time. So three types. First one is ARM7 3-stage pipeline. In that we will have 3 stages. First one is fetch, then decode, then execute. Okay, so let's see by one example. The task is to add 2 numbers, then subtract and compare 2 numbers. Okay, so these are the 3 tasks. In the first cycle, what will happen? It will fetch the instruction add. Okay, that's the first step. In the second cycle, what will happen? It will decode the add instruction. At the same time, it will fetch the next instruction, which is subtract. In the third cycle, it will execute the first instruction, which is add, sub instruction, and it will fetch the next instruction, which is compare. Okay, this will happen simultaneously. So that's known as pipelining. Similarly, we have more than 3, which is 5 instructions together, which is in ARM9, and 6 instructions together, which is in ARM10. Okay, the concept remains same, but it's much more faster. Okay. Moving on, we have exceptions, interrupts, and vector tables. What is an exception? Exceptions and interrupts are closely related, which is whenever the normal execution is going on, if the exception happens or an interrupt happens, at that time the normal execution will stop and it will be serviced, which exception or the interrupt will be serviced first. Okay, so the exceptions happen due to various reasons, such as any error, or the supervised mode, or the privileged mode, or the processor fails to access some memory location. At that time exceptions happen. And interrupts happen whenever an input is coming, or we have to display something, or the processor needs to carry out some other memory access. Okay, that time interrupt happens. So these interrupts and the exceptions need to be classified and kept in a separate space. Means see, these are the normal exceptions, which is reset, undefined instruction, software instruction, and prefetch, abort, and similar instructions are there. And whenever these instructions happen, at that time where the memory is to be going, means see, for example, interrupt request. Okay, interrupt request means the normal execution is going on. At that time user interrupts to input a value. Okay, at that time the processor should go to the location where the input can be taken. That location is given by the address in the vector table. This location is here, and the processor will go here by looking at the address from this vector table. So by completing that, it will return to the normal execution. This is known as vector table, and the exceptions and the address are given by it. The last topic is core extensions, which means the processor is present here and it has some extensions which are used for various purposes. So let's see what are those. There are 3 types. First one is cache. So cache will make the memory access much more faster. Okay, so suppose that this is the secondary memory and this is the ARM processor. In between these, cache is present so that the execution of the programs will be much more faster, because fetching of the data from the memory will be carried out by the cache, and the processor will be handling the execution of the instructions. Okay, and the second one is memory management. Since there are a lot of data members, it needs to be managed to be accessed faster and in much more easier. So a memory management device will be present near the processor, which will manage all the memory present inside the secondary storage. The third one is coprocessors. Coprocessor is nothing but the extension of the ARM processor, which will have the same features, which will make much more faster instruction execution of the ARM processor. Okay, so the instructions will be carried out with much more speed. Okay.